Okay, welcome back. Reinforcement learning. This session I explain the pre-processing and the queue network. Okay, in reinforcement learning, what are the pre-processing operations will perform on the queue network? We'll discuss in this session. The pre-processing and queue network section describes the transformation of high-dimensional data raw game states into manageable. In reinforcement learning, we are using the game environments. So, we transform the high-dimensional raw game states into manageable, efficient formats for training the reinforcement learning models. So, it outlines the step for the state reduction, transformation and representation to improve the computational efficiency and model accuracy. So, we are transform the high dimensional raw game states into lower dimensionals for in order to reduce the computational uh, overheads. So, this one raw state representation, generally raw states are the game environments video frames. The raw state is typically represented as RGB video frame with the dimensions for the Super Mario games. We have the 240, 256 and 3. So, the RGB game video frame, it is the RGB video frame for the Super Mario games. This high dimensional representation is computationally very expensive and does not provide any advantage for training the model. So, we need to apply the some pre-processing in order to reduce the computational expensive. So, the first this is the raw state representation. Each state given to the agent is a concatenation of the three most recent frames in the game. This is necessary so that the model can have access to not just the position of the object, but also their directions of movements also we are required in this game. So, we need to apply the pre-processing. This is the simple game state representation. We need to convert the RGB into grayscale. So, grayscale conversion and resizing to enhance the training efficiency for the RGB frames are converted into grayscale and resize the dimensions into lower sizes. In this example, we are reduce the dimensions to 42 by 42 pixels. This transformation allows the model to focus on the most relevant features of the input data and significantly reducing the amount of data processing. So, the RGB high dimensional is converted to grayscale and also we reduce the dimensionals also. Dimensionality also we are reduced from lower dimensions. So, 3 dimensions will be converted to 2 by 2 dimensionals. The functions in pre-processing we are generally applied the downscale or underscore OBS. This function is responsible for downscaling the observation frames. OBS means observation frames. So, downscale OBS function we applied to downscale the observation frames and converting them to grayscale required. The parameters here OBS, the state array observation to be processed. This is the state representation and the new size, the tuple indicating the new size for the height and width. To gray, a boolean flag indicating whether to convert the image into grayscale or not. Okay, these three parameters we are using in downscale OBS function, observation function. OBS is the state array to be processed, which frame we are processed, that is the OBS. New size, what is the rescaling size, and to gray, it is needed to convert into grayscale or not. So, it returns the downscaled image either in grayscale or RGB format. If to gray boolean value is the false, it is in RGB format. It is true, it is RGB, it is grayscale format. So, depending on the to gray parameter, we can it is returns the grayscale or RGB frame. The implementation from SkyMatch dot transform import resize downscale OBS new size 42 by 42 grayscale is true. So, we apply the grayscale is into the frame is converted into 42 by 42 size in grayscale format. One more function is prepare underscore state. Prepare underscore state is the function prepares the single state by resizing the image converting to the grayscale. It is prepares a single state, it prepares the only a single state uh, prepare a single state by resizing the image, converting to grayscale and converting to the PyTorch tensor. So it is the import the torch, which is prepare dot state underscore state. We need the state only. So it returns the values. If the gray is true, it is the grayscale image. Okay. Only it is prepare a single state by resizing the image. Then the third one is prepared underscore multi-state. So instead of single state, we are using multi-state. This function updates the channel dimension of existing state tensor with a new frame. It is used during the testing to maintain the last 3 frames. So here multi-states. So state 1, state 2. Definitely multi-state, state 1, 2. So it is either written as a grayscale or RGB based on two gray Boolean value. It is the true, it is written the grayscale image. So prepare underscore multi-state is the function update the channel dimension of an existing state tensor with the new frame. And fourth one is prepare underscore initial state. This function prepares the initial state when stating the game, creating the tensor with the 3 copies of the first frame. 3 copies of the first frame. This is the function prepares. It prepares the initial state when stating the game, creating the tensors with the different copies. Okay, here 3 copies of the first frame. So it creates the initial state. Prepare the initial states. It is either gray or RGB based on 2 gray Boolean parameter. And visualization. To visualize the pre-processed frames, you can use the MATLAB lib Python library for to represent the frames. The import matplotlib pyplot as PLT, plot IM image show environment render RGB.array, plot IM show downscale observation env.render RGB array. We display the visualization of the pre-processing frames using matplotlib. So to the pre-processing step is a very essential in reinforcement learning training process. It reduces the computational expenses. So by reducing the dimensionality of the input data and focusing the most relevant features, we can improve the efficiency and effectiveness of the reinforcement learning models. Thank you.